Okay, for this next part, I'll show you why this here is a solution to this special type of coupled differential equation that we saw above. And so we're going to verify that this works. It is a solution to that. Means it is an antiderivative of this. So we can integrate this one to get this one. Well, instead of integrating this one, because we know that it's really hard sometimes to integrate when we have a coupled system, both in terms of x and y, not so easy, but it's easier to show why we can take the derivative of this and show that it is equal to that. So the derivative of this, well, remember, this is x, this is vector. The derivative with respect to t would be that vector derivative with respect to t. So we have x, that vector, okay, equals, this is going to be a tough derivative. We have the derivative of this term here with respect to t. Well, remember, if we had like y equals e to the 3t, if I wanted to find dy dt here, so the derivative of that with respect to t, let me erase that chunk, would be 3e to the 3t. So we want to do the same thing here. The derivative of the numerator, or sorry, not the numerator, sorry, the exponent is lambda 1. We're going to bring that out front. So we have a lambda 1 e to the lambda 1 t. And the next, those are just more numbers, like that is a vector, right? And so it's not in terms of t, it's a multiply, it's a product here, but it's not a vector in terms of t, it's just numbers. And so that stays the same. So vector p1 stays. Plus, same idea over here, b lambda 2 e to the lambda 2 t. Remember that lambda 1 p1 is equal to the matrix M times P1, and lambda 2 P2 is equal to the matrix times P2. Well, that means that we can replace lambda 1 P1 with M P1 over here. And in the second part, lambda 2, I forgot the P2. That would be important. I'm going to write it here. It's still there. Gets replaced with M P2. And that was what we had seen above. I showed you that a moment ago above in the last video. So we're going to do some replacement. So we have a m e to the lambda 1 t p1 plus b m e to the lambda 2 t p2. We can factor out the m. And we have a e to the lambda 1 t p1 plus b e lambda 2 t p2. And we're really lucky because this is the same as that. So we can replace one more time. And finally, what we end up with is the derivative is equal to m times x, which is what this up here is saying, the derivative. Remember, another way to write this would be the derivative of x with respect to t. The vector includes the x and the y equals the matrix times the vector not derivative xy. We're just going to represent with plain x, which is what we got here. So we just showed that the derivative is equal to that. If you got that, great. If not, we'll move on to how to actually do a problem in the next two videos.